Welcome to Text Mining module. My name is Insuk Chang, and I'm a doctoral student at Carolina Health Informatics program at UNC at Chapel Hill. Today, I will talk about predictive analysis of text data. Before we go into today's topic, let me explain why we perform predictive analysis of text data. There are hundreds of books published every day, and we cannot catch up with the speed of publication, nor do we have time to search for books that interest us. If we have a bunch of books already annotated, whether they attracted my interest or not, a machine can be trained using an algorithm to learn from those annotations which labels are related to contents of corresponding books. And we can later use these algorithms to predict whether a new previously unseen book will attract my interest based on its content. In this way, I can save time and labor spent previously searching books for myself. This is an example of a text mining technique called predictive analysis. Predictive analysis of text data can also be used in spam filtering, predicting fake news, sentiment analysis of product reviews, and predicting readmission from patient note. In this module, we will predict relevance of articles to a systematic review of AC inhibitors. To do this predictive task, we go through several steps. If we recall, we reviewed the first two steps, pre-processing text and creating feature representation. The remaining steps are selecting features to reduce the dimensionality of features, splitting the dataset into train and test sets, conducting predictive analysis, and comparing the performance of each prediction model. First, let me talk about feature selection or dimensionality reduction. In Text Mining Module 4, you learned about feature representation. I would like to continue the story by introducing the idea of feature selection or dimensionality reduction. In this module, we will use a dataset that contains 9,449 unique words. That is, my dataset has 9,449 columns. But are each of those words important? No. Some words such as AA and AAA may not be important in deciding whether the articles are relevant for the topic. These unimportant words may only give noise to the dataset. Less misleading data means model accuracy improves. In addition, fewer dimensions means less computing. Less data means that algorithms train faster. We need to reduce the number of words or features not only to reduce computational capacity, but also to make our model stronger. With only a handful of features at hand, we can produce a more efficient prediction algorithm. PCA and Chisquared are the two most widely used methods for dimensionality reduction. PCA is an unsupervised method, that is, you don't need annotated data to train the algorithm on how to decide which feature is important. I will not go into too much detail on how PCA is actually calculated. Chi-squared methods need annotated data, that is, the target class of each instance in the training dataset should be already determined. What chi-squared measures is a co-occurrence statistics that occur between individual words and target classes. Every instance in the dataset will fall under one of these quadrants. And with this equation, we can measure how a word W is correlated with class 1. The larger the word W is correlated with class 1, the larger the chi-squared score it gets. In this module, we will use the chi-squared method for predictive analysis since we have an annotated dataset. Next, we need to split the whole dataset into training and testing datasets. So far, we have reduced the dimensionality of features, and we will later build a classification model based on the dataset we have. But is it reasonable to test the performance of my model onto the same dataset that I used for building the model? No, in that case, we are testing the performance of the model on the same observations, and the training error will underestimate the true error rate of the model. The rule I had built should be generalizable to the data it has never seen before. But often it is not easy to obtain a new data set upon which I can test the performance of my model because of a variety of logistical reasons. So it would be reasonable to split the data I have into training and testing data sets. The training set is used to train the model, and the testing set is used to validate it on a data it has never seen before. The classic approach is to do a simple 80 to 20% split, sometimes with different values like 70 to 30 or 90 to 10%. In our dataset, we will use the Jupyter Notebook. The total number of instances is 2235. We will split the data using a ratio of 80 to 20, and we will have a training set of 1788 instances and a testing set of 447 instances. Now we have reduced the number of features and training and testing data sets. What we will do next is building a classification rule based on the training dataset and predict the label of each instance in the testing dataset. In this module, we will use logistic regression and k-nearest neighbor.